G'day, I'm Adam. I'm an engineer at Zoo.dev, where we're making a new CAD suite called Zoo Design Studio. This is part of a video tutorial series where I'm teaching you how to use KCL, the kitty cat language. This is a programming language we built for 3D design. So it's a programming language for CAD. In previous episodes, I've kind of showed you the basics of KCL, walking you through how to use it in the very basic level, to making 2D sketches, how to make those 2D sketches into 3D solids, and then how to do different things with those 3D solids, like fillet their edges, transform them, rotate them, apply color, CSG. Today I want to talk about something a little bit different. Today I want to talk about parametric design and how you can do that in KCL. So let's get started. You can see here in the video we've got a flange, right? We've got this kind of disc shape with a bunch of holes cut into it. We've got 8 holes cut into it. This is one specific flange, right? It has a specific diameter, it's got a specific number of holes, it's got a very specific height. It has some properties we can measure. This is what we would call direct modeling in the CAD world. You've made one specific part with some specific physical properties. But there's another way to do CAD design, which is called parametric design. In a parametric design, you don't just give one specific part with its specific measurements. You kind of define a general part with many possible properties. So we could make a recipe for flanges in general, where you choose the specific depth you want, the specific diameter you want, the specific number of holes it should have, and then your model kind of acts on those parameters and outputs a specific flange. So parametric design is where you give a kind of general abstract recipe for the part, and you let the user choose which parameters it should have, like how many holes. And then your parametric design will become a specific instance of that kind of design with specific physical properties. So let's see an example of that. We've got this specific part here, and we're going to turn it into a parametric part instead. So I'm going to make, in KCL, the main way we do this is functions. I'm going to make a function called flange. Function flange. And at first, it's just going to return this specific flange. We're going to say return base, and then we're going to call this function. So we've got this function flange. It first defines the holes you cut in, then it defines the disk, which is a circle with those holes cut out of it, and it's extruded. So we call flange, and we get this specific flange out. Now I want to make this parametric. So in programming, functions take a number of parameters, or they're often called arguments instead. And we're going to add some parameters, or arguments, to this function to make it parametric. Right now, it always outputs a flange with, radius 60 and depth 10 and 8 holes. But let's make those specific values parameters instead. Let's say this takes in a diameter and a number of holes and a thickness. We're going to change these values. So we can define the radius. We can say radius equals diameter divided by 2. We're going to change this radius to just be the radius we gave it. We're going to change the number of holes here. It won't be 8, it'll be whatever the user provided now. And we're going to change the extrusion length to be whatever thickness the user provided. So if we give the old values, we can put in all these arguments here. We can say that diameter equals 10, and num holes equal 8, and thickness equals 10 as well. I think the diameter should be bigger. Should be something like 100 actually. Maybe 200. There we go. So now we've given slightly different parameters and we're getting a slightly different flange out. We can change the diameter to be 150 instead. And our flange rearranges itself. We can change number of holes to be 16 holes instead. And we get a different flange again. We can change the thickness to be even thicker. And we get a really different flange. So by defining this flange not as one specific variable, not as a specific direct modeling thing, but when we define it as a function, we can easily give it parameters, which means you can do parametric design. Now, if we wanted to put in a limit, like say this flange should only ever have a maximum of 20 holes, right? Because you can see if we try to put more holes at a certain point, it won't really work. Let's try. Does it look good with 20 holes? Yeah, it does. But if we try and put in, say, 40 holes, that's probably going to be kind of broken, right? That model doesn't really work out. The holes are too close together to be useful. So we can put in a little assert here to say that this has limits. We can say assert that num holes is less than or equal to 30. Which means we now get an error when you try and call it. The error says expected 40 to be less than or equal to 30, but it wasn't. And we can put in a little helpful error message in it and say, instead, we can say, just called error equals this flange design only supports up to 30 holes. Now, if we mouse over the error, we can see that it says, the more useful error message. So we can use that to kind of put limits on the parameters that users can provide. We can also validate the parameters as well, like, the diameter should be a positive number, of course, right? It doesn't make sense to have a diameter of -4. What happens if we try and put a negative diameter in? No, we have to change this because the assertion is still triggering. Let's say go back to, 24 holes. Well, now we get an error here because it says the circle can't have a negative radius. But if we want, we can put in pre-validation up here. We can just say assert that diameter is greater than 10. Error equals the diameter should be larger than 10. Otherwise, the flange will be too small. And now we get a more useful error message, right? That little assertion pops up. And these assertions are really helpful for checking that the user provided realistic parameters. So yeah, we've seen that we can make a parametric flange, and you can put in all different kinds of values into it. We should probably have something to validate that the diameter is big enough to actually stand all these circles. So we put in a more realistic thing, like the diameter should be greater than 150 actually for this example, maybe. Or I guess 130, because with 140 it still looked fine. Yeah. So that's your basic how to make a parametric design in KCL. And we can combine this parametric design with transformation functions like we've used previously, like translating and rotating. We can create many flanges in the same scene. So let's make another flange. We'll say this one has diameter equals 200, num holes equals, 8, and thickness equals 10. Well, we've made two flanges now, and you can see they're overlapping each other. So we've got two flanges in this scene now, and if we want, we can move them apart. We can just take the second flange here, and we can say, let's translate it, and let's move it across 200 in the x-plane. Yeah, so now we can see many different flanges together. You can kind of call the flange function with different parameters and get a different design each time. And that'll be quite helpful because you can kind of make a couple of different designs and you can compare them, you can measure them, you can use them in different ways. So you can see that by defining KCL functions, we can take one specific design and we can make it into a parametric design. And then users can put in different parameters and get different specific designs out. You can validate these parameters using the assert function, and then you can call this function many times with similar or different parameters to see what they look like. You can translate them and move them around. You can give them different colors if you want to. Let's put in color equals, So yeah, you can give them all kinds of different properties and different specific instantiations. Of course, we could, add even more parameters to this. We could say, have a parameter for how far the holes are, for how close to the center or how close to the circumference the holes are, shifting them in and out of the center of the flange. You can, go pretty wild and adding all kinds of parameters, but I would think about which parameters are the engineers likely to actually care about? Which parameters are they likely to actually change? Which parameters should really just stay the same because you're never going to want to change them. So you can always kind of add or remove parameters as you need to. But yeah, I hope you found this little guide to parametric design in KCL helpful. I think it's one of the interesting things about KCL. I think that functions are a really natural fit for parametric design. That's because they have parameters. The key is right there in the name. So thanks so much for listening. Hope you enjoyed. Take care.